Okay, with this session, we'll be reviewing some of our algebra skills involving adding and subtracting, multiplying, simplifying basic fractions that involve a bit of algebra, and expanding and simplifying. When adding or subtracting algebra or expressions that involve algebra, all you have to do is remember you can only add what I say apples with apples and bananas with bananas as a way for you to remember. And that is, first of all, check your operations. We can see here we have addition in between everything. And even if there was subtraction, a minus somewhere, we know that because of that, we can only add or subtract like terms. And like terms means anything that's the same. So if you start, in this case, it's all positive. So if we have a look at the first variable, we've got an A here. And it's telling us we have two A's, just like two apples. Do you see any other A's or apples in this expression? We notice there's an A here. They're exactly the same. And so I'll add them together. 2A plus 5A, or 2 apples plus 5 apples, is simply 7 apples. But we just have A instead. You can cross it off if it helps with your working out. We're not finished yet because we still have B to simplify. Now it's all positive, so positive 2 plus 6. Well, 2 plus 6 is 8, so it's positive 8B, or B for bananas. And that is all we can do. We can't add these together because they're two different things. A is different to B. They're not like terms, so that is our final answer. Okay, our next question, we'll be doing the same thing because we can see our operations are addition and subtraction. And when we see that, we are only adding like terms. Now, always to start with your first variable. In this case, we've got x squared. Now, do you see any other x squareds in the whole expression? If you don't, then you can't add anything to x squared and you leave it the way it is. X is not the same as x squared. The power is 1 here, so they're two different things. Here we've got an x squared, so I can see that they're the same thing. So I can add or subtract these two terms. Now, look at the number or the coefficient in front of x squared. The coefficient means the number in front of the variable. In this case, we have x squared. So there's a 2 there. We know it's a positive 2. We always look to the left. And here we have a 10, and it is negative. So what you can do is circle, what I usually do is circle the whole thing before I start, when I notice there are a lot of negatives and positives. That's the only negative I have. Everything else is positive. So what is 2 minus 10? Okay, or 2x squared minus 10x squared. So you can use your calculator as a tool to help you. But we know 2 is a small number. So 2 take away 10 will leave me with negative 8. But it's negative 8x squared. And I'll cross it off because I've used it. And what's left? Well, we've got an x here, or positive 5x. Is there an x in this expression on its own? Yes, there is. There is one here. We know there is an invisible one in front of that x. So now we can add them together. 5x plus 1x makes a positive 6x. And that is our final answer. Okay, with our next question, we'll start off by circling our positives and negatives to what they belong. So always to the left, that A is a positive A, that is a negative 10y squared x cubed, a positive 2ab, and that's a positive 7 x cubed y squared. You don't have to do this, but if you make mistakes with your negatives and positives, it's a way you can start to make sure you don't make a mistake. Now, starting off with our first term, and we can see there's 7, and what 7 things we have? We've got x cubed and y squared. Now check every other term in the expression to see if you see an x cubed and a y squared, and order doesn't matter. So just have a quick look. That's AB, it's completely different. Here we've got y squared and x cubed. Well, let's check. Is there an x cubed here? Yes and yes. Is there a y squared? Yes and yes. Even though the y squared is first, it doesn't matter because we are multiplying in between the y squared and x squared. There is multiplication. There's a times there. And just quickly, if we have, for example, 2 times 3 times 4, that is equal to, well, 2 times 3 is 12, and 2 times 3 is 6, and 6 times 4 is 24. Now, if I change the order of 2, 3, and 4, if I wrote it this way, just say 3 times 2 times 4 instead, let's see if we get 24. 3 times 2 is 6, and 6 times 4 is 24. And if we did it again, 4 times 2 times 3, different order, we still get 24. So when multiplying numbers, we can see that order doesn't matter. And y squared times x cubed, they are actually numbers. We don't know what y is and what x is. If we did, we could then evaluate and find out what the numbers are. But because we don't, we just leave it in algebra form. But they are the exact same number. It will be the exact same number over here and over here because we have the same thing, x cubed, y squared, x cubed, y squared. So we can add them as like terms. So positive 7 minus 10. So 7 minus 10 will take us in a negative region. And the difference between 7 and 10 is 3. So negative 3. And we have negative 3, x cubed, and y squared. We can see how the variables x cubed and y squared did not change at all. That is because we are adding and subtracting like terms only. We can cross it off now that we've done that. And now we've got the AB. Do you see any other ABs in the whole thing? Over here we've got an A, just I was able to squeeze that A in. It is different to AB because there is no B there, so we can't add anything else. So that's a positive to AB plus A. There's nothing else we can add or subtract because there's nothing that's the same, no like terms, so we stop there. Now, when multiplying algebra, what we do is a little bit different to adding and subtracting because that's where the powers can change. Now, before we look at that, we'll look at a more basic example. We've got A, B, and C. In between A, B, and C, there is an invisible times. So if you had a question that asked you to simplify this, for example, A times B times C, and the question said, can you simplify this? Well, all you had to do is make the multiplication sign invisible, and you would end up with A, B, and C. So with algebra, we know that when we have letters sitting together or variables sitting together, or even a number, if I put a 2 there, there's actually a times in between everything. That's saying 2 times A times B times C. We don't know what A, B, and C are, so we just leave our answer like that. Now, just quickly to recap on what happens, to understand what happens when we multiply the same bases or the same variables. If we have 2 to the power of 3, we know that is saying 2 times 2 times 2. And 2 times 2 is 4, and 4 times 2 is 8. Now, if I had, instead of 2 to the power of 3, or 2 cubed, if I have A cubed, it is actually telling me the same thing. Even though A, we don't know what A is, it's still a number, and we still have A times A times A. And to go back to this, that's where we add the invisible power 1. That 2 also has an invisible power 1. That's why 2 times 2 times 2 equals 2 to the power of 3. And we know that when we multiply the same numbers or the same base, we add the powers of the same base. In this case, we could add the powers of A because A times A times A is the same variable. It's the same number, just like the base 2 up here. So with this question, all you're going to do is first of all check your operation. We are multiplying. We're not adding or subtracting. It's very important that you establish that because if we had A squared plus A to the power of 4, and we'll put it plus A to the power of 3. If I change multiplication to addition and had to simplify this, I couldn't because A squared is different to A to the power of 4 and different to A cubed. And we can't add anything. Nothing's the same. Just say that was an A squared were apples. Are there any other apples that I have here? No. But up here, because we have multiplication, it is now different. That is where we can add the powers of the same base. Now, and also the multiplication symbol will become invisible. So have a look at what bases you see. We've got A and A and A. So my answer will have an A in it. And now just add the powers. 2 plus 4 plus 3. Well, 2 plus 4 is 6, and 6 plus 3 is 9. And we're done. Okay, with our next question, A way to simplify this, so we have to simplify. Check your operation. We are multiplying everything. So when you see multiplication in between everything, it'll all become invisible. And you have one big, what I call a big blob. So a way to do this is, first write down the different bases or different letters that you see. There are no numbers. So the different letters I see, I've got an A, and that's another A there. I've got a B, and I have a C. And that is going to be your answer. The only thing now you have to add in are the powers, and only add the powers of the same base. So we've got A and A here, same base, so I can add their powers. 6 plus 7, we've got 13. The A's, we can cross them off now. B to the power of 3. Are there any other B's in the whole expression? No. So the power 3 stays the same, and C squared stays the same because there's no other C's. And we're done. That's our final answer. And we can see that the multiplication symbol became invisible. Okay, with our next question, it might look a bit confusing because we've got 2a squared b instead of everything being spread out by multiplication. But remember, this is the same as having 2 times a squared times b times, and so on, 4 times a cubed times b. That is the same as this. It's just that the times is invisible in between there. So don't let that confuse you, where you think you've got these numbers and variables together. So when you have numbers, because we know what the numbers are, all we have to do is multiply our numbers. So starting with our numbers, 2 times 4 is 8. And cross it off because we've dealt with it. The next thing we can do is, well, let's write down all the different variables, the different letters we see. We've got A, B, A, B. So the 2 different letters I have are A and B. And now add the powers of A and add the powers of B, and we're done. So looking at our A, we've got 2 A's here. So 2 plus 3, that is 5. I can cross it off because I've used it. And the invisible 1 plus 1 makes B squared. And that's our final answer. Now our next question involves negative values. Now, if you're not confident with your negative numbers, just remember when we multiply 2 negatives, they will make a positive. So you may need to revise your negative number skills, but of course you have your calculator there to assist you. Now, when we see something like this, we've got negative 5b squared times a negative 2bc. So this part here is not saying it's not saying times and subtract. It's saying multiplying a negative value. So the operation is multiplication. And sometimes your textbook, for example, may have brackets around the negative 2bc. And the reason is it is showing you that we are multiplying a negative value. The brackets don't have to be there because there's nothing outside the brackets or no power up here. So I've put the brackets here to emphasize that we're simply multiplying by a negative value. And sometimes the textbook may show that, but the brackets don't have to be there. So all we're going to do is multiply our numbers first. So we've got negative 5 times negative 2. Well, 2 negatives will make a positive, and 5 times 2 is 10. And I can cross that off. Next, the variables I see is B, a B there as well, and a C. So my 2 different variables, my 2 bases will be B and C. And now add the powers of the same base. 2 B's here plus 1 B there. That makes 3. I can cross that off. And I've got 1 C sitting here. No other C's, so that's my final answer. Now with algebraic fractions, now there is another lesson on this, but just to quickly recap, if I had 2 over 2 and I had to simplify this, well, we'd divide by the same factor, which would be 2, divided by 2 or divided by 2. Or because we see we have the same number, we just cross it off and it cancels out to be 1. So 1 over 1, which is equals 1. So with algebra, we are doing the same thing because A, for example, could be the number 2, but we don't know what A is. It represents a number that we don't know, but we do the same thing. We either divide by A and divide by A It's like saying dividing by 2 or dividing by 2. Or we can say we can cancel it out and it becomes a 1 and a 1. And we end up with the same result. Because the same number on the top and bottom will always equal 1. Just like 2 divided by 2 is 1. Now, what happens when we have powers? Now, all you have to do is look at this as though we have 2 A's on top and 5 A's on the bottom. And you can always take away your smallest amount. So if I've got 2 A's and 5 A's, well, the smallest amount is 2. So up here, I can only take out 2 factors of A. And what I do to the top, I must do to the bottom. So if I take away 2 from the top, don't put a 0, it's really a 1, because what we're actually doing is we've actually divided by A squared. So what I do to the top, I must do to the bottom. And down here, 5 take away 2 A's leaves me with A to the power of 3. So I'm left with 1 over A to the power of 3. Okay, with this one here, now we notice we have numbers 2 and 4. So with numbers, imagine you had 2 over 4 as a fraction. You simplify it the same way you would simplify a normal fraction. And to simplify fractions, we must divide by the same factor, top and bottom. And in this case, the highest factor is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I get my half. I'll just change my color. So same thing here. 2 divided by 2 is just 1. And 4 divided by 2 is 2. So far I have 1 and 2. I'll leave my 1 there in case there's nothing left on top. Now, if I have a look at my variables, yes, I've got an x on the top and an x on the bottom, so I can cancel those out. It's the same number, same amount, it's gone, just a 1. Y and y also, same number, same amount, so it's gone, just a 1. Now, see how we have the 1s left over? Don't just keep writing 1 and 1. That looks like 111. Remember, in between 2 and x there's a times, in between x and y there's times. So 1 times 1 times 1 is just 1. So just write 1 once in case we do need it there. And we're left with a z on top. Do you see any z's on the bottom? No, so we can't cross it off, so it stays on top. And the t on the bottom, no t's on top, so that also stays on the bottom. Now this one here can become invisible because we ended up having a z on top. And that is our final answer. The next thing we'll be looking at is expanding. And when you see expanding and algebra, you have to have something like this. You'll notice there are brackets. Okay? And the opposite of factorizing, the opposite to expanding is factorizing, which we will be doing later. Now, in between this 2 and the brackets, we know there's an invisible times there. And all you have to do is use the distributive law. And to distribute something means to share to everybody. Just say we're distributing evenly, we're sharing evenly. So think of that, and you can see this 2 out here is distributed or multiplied with the x and the 3. So the number on the outside is multiplied with everything on the inside that is separated by a plus or a takeaway. In this case, we've only got x plus 3. So 2 times x is just 2x, and what I'll do is I'll put the plus down, and 2 times 3 is 6. And just double check, can we add 2x plus 6? No, we can't. There's a plus here, not a times, and we don't have an x sitting here, so it's 2x plus 6, we stop there. Okay, with this question here, once again, we have brackets. We have to expand this, and then we know there's a times in between the 2 and the brackets. So if it helps, do arrows so you don't forget. We've got 2 times x, 2 times 3, 2 times y, and 2 times 2t. Now, be careful with your positives and negatives, and I'll show you a way that I guess is simple and the way I do it so you don't get confused. That's a positive 2, keep that in mind. So now we've got 2 times x, well, that's just going to be 2x, the times becomes invisible, plus, and then we have 2 times 3, which is just 6. Another plus here, so put the plus down. 2 times a y is just 2y. Take away put a takeaway there or negative, and 2 times 2 is 4, and then t just sits there. And that's it. And this one you could have done mentally. So 2 times x is just 2x. And if you've forgotten that, just remember that 2 times, if I had the question 2 times x, there's nothing else we can do. So this times just becomes invisible. Now, when questions start to get a little bit more complicated in terms of the variables and powers, you can show some working out if you can't do it mentally at this stage, and that's fine. So once again, we'll do our arrows to make sure we don't forget to multiply something. So now we're saying 2x times 5x. So I'm going to show working out for this one. And to do this, what you can do is just go 2x times 5x. So 2x times 5x. And if you want to, put it in brackets to say, yep, we've got 2x times 5x, which is something we've got to do together or first. Plus goes in the middle because there's a plus there. And then we have 2x times 6y x squared. 6y x squared. Just squeeze it in, and I'll put a bracket there. And that's showing some working out. And now all we have to do is simplify what we have in the brackets. And don't forget there is a plus in between these two terms, or expressions in this case. So now 2x times 5x. Well, once again, we've got times in the middle. So we multiply our numbers. 2 times 5 is 10. And x times x, because it's the same letter, it's going to be an x down there. But I add the powers of the same variable. So 1 plus 1 is 2. Got my plus down there. Excuse the big gap. And now once again, there's a times. We're multiplying 2x in this term here. So multiply your numbers. 2 times 6, yep, that's 12. And now let's see my bases, my variables. I've got an x here, a y there, and an x there. So the two different variables I see are x and y. And of course, add the powers of the same base. So x here is 1. So 1 plus the 2 makes 3 x's. And the y just sitting there stays the same. And that's our final answer. With this question here, you know there's no number but a negative out there. Now there is actually a number, which is the invisible 1. And we're saying minus 1 times x minus 1 times that 2, which is really a negative 2, and minus 2 times that t, which is a negative t. So here you have to be careful with your negative numbers, and we can see that we'll be ending up with some positives. So let's do one thing at a time. So minus 1, and if it helps, you can circle, that's a negative t and a negative 2 and a positive x. You can do that to help you. So we've got minus 1 times a positive t, well, minus 1 times a positive x is minus x. Minus 1 times minus 2, that will give us positive 2. And minus 1 times minus t will be positive t. And that's it. You notice how all our variables and numbers stayed the same. It was just the positive or negative changing. And we got the opposite. A positive here became a negative became a positive, and a negative became a positive. So with your negative, if you notice there's a negative out here, just keep in mind that everything inside the bracket, whether it's a negative or a positive, will become the opposite basically. So our last question, with this one, you notice we have two different brackets, or sets of brackets, and there's a plus in between them. So we'll expand each side and then simplify if we can. So the question would be expand and simplify. So 2 times x and 2, also negative 2 times x, and here we've got that times that. So let's work on this side first. So notice it's a negative 2 out here, so please be careful. So minus 2 times x is just minus 2x. Minus 2 times a positive 3 will make a negative 6. Plus, it's just there. Now, it's important that, see that plus, if that was a negative, it would actually belong to this 3, and we would have negative 3. Because it's a positive, that 3 is just a positive, so nothing will change in here. So keep that in mind. If you had a negative out here instead of a positive, it would really be negative 3 times x, and negative 3 times that positive 3. So just keep that in mind in case you have a question like that. But because it's a positive 3, you can circle it if you want to. Positive 3 times x is just 3x. And positive 3 times a positive 9. Positive 3 times a positive 3 is positive 9. Now, we don't stop here. We have expanded, but we can continue simplifying now. And you notice that we have negatives and positives. There's no times in between everything. So we can only add like terms. So we've got, what I'm going to do is circle to the left, just so I don't make a mistake with my negatives. And I have minus 2x. Now, I've got an x here and an x there. Same number or same variable. So minus 2x's plus 3x's leaves me with 1x or just x. And that 1 can be invisible, but I just put it there to show you that minus 2 plus 3 makes a 1. Cross it off. We're done with that. Now, minus 6 plus 9. Well, minus 6 plus 9, they're both numbers or constants, so we can add them. There's nothing else attached to them there. So minus 6 plus 9, well, the difference is 3, and we're in the positive end, so positive 3. So your final answer would just be x plus 3. So please make sure when the question says expand and simplify, that you expand it and then check what you can add or subtract together. And they can only be the same or they can only be like terms. Thank you.